Hello, Mr. Jordan. This is my Chapter 4 video review, also video review Chapter 7, or video review 7. So the chapter was broke up into different sections. The first one was Conquest of Outer Space. The second one was Space Tech of the Present. Third was Exploring Earth's Neighbors. Fourth was Satellites. The fifth was Future Exploration of Mars. And then the last one is Bioastronautics. So, starting out, the conquest of outer space. The 50s and 60s is where this kind of began. The Cold War started this. We were in a battle with the USSR. They originally launched Sputnik, which was the first satellite launched into space, which came as a surprise to the United States. And the United States responded with the Apollo missions, which ended up putting a man on the moon and had a couple successful orbital missions, including my favorite one, Apollo 13, which is the failed moon landing attempt. The next section, the space tech of the present, talked about space shuttles, Mir, the ISS, and the telescopes of outer space. So the space shuttles, basically what NASA was pushed for was launching rockets was extremely expensive, and they wanted something that they could reuse. So by this I meant reuse the thrusters, the body, the spacecraft itself, something that could be used for exit and re-entry multiple times is why the space shuttle was commissioned. They brought about, I believe, the 1980s, and by the 1990s they kind of had it perfected. There was a couple tragedies, of course, with like the Challenger and the next in 2003, but overall the space shuttle was deemed a success. The next one, Mir, is the Russian space station. It was the first outer space station. The USS responded with the Freedom. They had something called Skylab in the 1970s, which was a lot smaller. Freedom space station came in the 1980s, and it was later changed to the ISS in the 1990s because of the European Space Association role in creating all the technology for it. When it got remodeled, they also renamed it the ISS. As far as telescopes, I find this super interesting because one of my teachers at JUCO was actually part of the design team for the Hubble Space Telescope. The Hubble Space Telescope picks up optical and UV images, and it's led to some of the coolest images I've ever seen. It's fascinating. Going to Hutchinson Community College and seeing the Cosmosphere kind of blows your mind. The next one was Chandra. It took X-ray photos. Compton, which measured gamma rays, and Spitzer, which detected infrared energy. So, now that we've talked about the first two, we're getting on to the third one here. It's Exploring Earth's Neighbors. The first one, Sun. You have the Ulysses spacecraft, which is used to measure solar wind, and SOHO, which is measuring the surface and the atmosphere of the sun. The moon, we have obviously the Apollo missions and Smart 1. As you know, we have a moon rover out there that takes samples of the Earth, or the makeup of the moon. Jupiter, we have Galileo, which sent a probe down that relays it to Galileo, which relays it back to us. Asteroids, the NEAR program. Shoemaker was the name of the thing there. It's part of NASA's program to launch cheaper, more simplistic things. So that is used to research near Earth asteroids, or asteroids that will collide with Earth, and I believe that one's about 1.5 million years. So Saturn, we have Cassini. That was just pretty much all of these are just sent to take samples and relay back to NASA what the composition of these planets. So Mercury, we have Messenger, sent for research of the planet. Mars, we have the Mariners, the Mars rovers, Challenge, I believe, what's that called? I'm drawing a blank on it. I didn't write it down. The next one, we have the satellites. Satellite orbit occurs about 22,300 miles from the surface of the Earth on the orbital plane. Typically, things stay in orbit on the orbital plane unless they make contact with another object that throws them out of orbit. As Newton's law says, each reaction is an equal and opposite reaction. Even though there's no gravity in space, that's how they're able to move around in space, by creating a reaction. There's another reaction. So the next one is commercial satellite development. There's been satellites developed for communication, television, and then we also have Starlink satellites that Elon Musk put up there in SpaceX that aim to give people internet in parts of the world that haven't had access to it yet, which is extremely cool. And then military applications. Military applications actually gave us the GPS, the Global Positioning System. Originally, GPS was made to let the military know where their troops were at all times, but since then it has become quite the civilian tool. I mean, we use it all the time. We use it for vacation. I use it to hunt, scout, everything. Rarely a day goes by where we don't use some sort of GPS. The next was the future exploration of Mars. Obviously, people want to put man on Mars, something we can't quite do yet because of how long it takes to get there and the extremes that occur on Mars. I believe they have things over there right now leading to proof that there was once life on Mars. I know they have discovered, I don't think it's glaciers, maybe things that are left from glaciers at one point on Mars, but future exploration of Mars interests me a lot because I think there's a lot to be discovered, and I think it's going to take some huge technological advancements, and I'm curious to see like the spin-offs from the technological advancements to see how it like can be implemented in our lives, because we've gotten a lot from space exploration in a roundabout way, and I'll talk about that after we're done here. So the next one is bioastronautics. It's the study of how space affects organisms like people. So the zero gravity syndrome, how people get nauseous in space, losing bone density, muscle tone, things like that, which they have stuff in the space station to help minimize that now too, with the spine expands. It's cool stuff. It's really cool stuff. So now I went on to watch the videos. Some really cool stuff. One that stuck out to me was the one by Mark Rober. It amazed me how much stuff we've gotten from space exploration, such as like the alloy that you develop for satellites used in braces and that sort of thing. GPS, how we've gotten GPS that we use every day now. Is space exploration needed? I think it is, just because I think humans are curious by nature, and there's been so many things that have been discovered that kind of revolutionize modern technology and just space. You do it because of the direct discoveries and the indirect ones. A lot of the research ends up giving us other products that we can use in our daily lives, not just in a satellite getting shot into outer space. So that's my opinion on that. This chapter actually really interested me. I used to be one hell of a space buff when I was younger, kind of a nerd. But yeah, that's pretty much all I have. Thank you for listening in, and we look forward to next week. Thank you.